So multiplying radicals is actually, it's kind of a review for you guys because in order to simplify radicals, you have to know how to multiply them. So like, you don't have to write this down. So like when we had root 24, we broke it down to root 4 times root what? 6, because root 4 times root 6 is 24. So you know how to multiply radicals. Okay? So in general, when we multiply them, if we got, why is it not letting me use purple? Turn off. Let's try this one. See if that works. Okay. So if we have some radical, and let's say that there's a number in front of it, so it's a mixed radical. And if we multiply it by another radical that has the same root or index, that's the same as multiplying the two coefficients in front, and then under a single radical, multiply the two radicals. Okay, we've seen that. Now, like with fractions, when you add, subtract, multiply, and divide, you always have to make sure to simplify or reduce. Okay, same thing with radicals. Whenever you have a final answer, it has to be simplified, which means we might have to find the highest perfect square to simplify it, or the highest perfect cube to simplify it. When we multiply radicals, usually we just multiply them and see if we can simplify after, like this. What is root 6 times root 10? Root 6. Can it be simplified?
Yes.
Yes. What can we break it down to?
6 is 6.
I hear quiet whispering. Sorry? 32? 30 and 2. Neither are perfect squares. No, that's it. Hey, at least you're taking a shot. Yes? 15. Which becomes 2 root 15. Good. What would this one be after I initially multiply it? 4 root 45. And it can be broken down. 9 and 5. Which becomes 4 times 3 root 5. Which becomes 12 root 5. Okay? That's it. Just so you know, you don't have to show these steps if you don't want to. Okay? If you're still sort of getting the hang of it, keep writing those steps. But if you feel that you can do them in your head, that's okay too. Okay, C. When I initially multiply, -6 root 40. Go ahead and simplify that. because it can be. I won't do it yet. What can I break it down to? 4 and 10 error. That is correct. Which means it becomes -6 times 2 root 10. Then I can multiply the -6 and 2 together, followed by a times root 10 to get -12 root 10. That's my simplified answer. This one. What looks potentially difficult about this equation or about this question? Yeah, you're going to get a big number. And that could be a pain to simplify. Okay? So depending on the question, what you should do when you encounter something like this, see if you can simplify first before you multiply. Can I take either of these square roots and simplify them? Yeah, roots. I can't do 2 root 7. But I could do root 75 by breaking it down to root 25 times root 3. So I get 2 root 7 times 4 times 5 root 3. And I mean, you could do all of the multiplication right here. When I multiply all the non-roots together, what do I get? 2 times 4 times 5. 40. And then the radicals, root 21. Okay. So that's the note I made above. But I left blank for the time being. Okay. Simplify first before multiplying. If possible. To avoid large numbers. That goes to that question we just did. I mean, you could have done it with this one too. You could have simplified root 8 and then multiplied after, and that's fine. You're still going to get the same answer. Okay, but root 8 times root 5 is not terribly large. Any questions? Okay. Okay. What's cube root 9 times cube root 6? Cube root 54. And again, I have to think about simplifying. Which it can be, but you got to change your thinking. You're no longer thinking perfect squares. You're thinking perfect cubes, of which there are fewer. So they are 1, which we never use, 8, 27, 64, now I'm too big, so it's 8 or 27. 27. And this would be 2. And the cube root of 27, 3, and then I've got cube root. This one, we've got some exponents and variables thrown in. Well, when I do my initial multiplication, what would I get? -8 and then root 22 y to the 4th. So remember, this y is same as y to the 1st. And what did we do when we encountered these things? Split and simplify each. So I get -8 and then root 22 and then root y to the 4th. Can I do anything with root 22? No. I can't take it exactly. There's no perfect square that goes into it. How about y to the 4th? Square root y to the 4th. Is there a highest perfect square, or could I take it exactly? Take it exactly to get y squared. Remember, when you square root an exponent, have it. Cut it in half. And then put the non-radicals in front and the radical at the end, and you're done. Okay? So those are multiplying single mixed or entire radicals by a single mixed or entire radicals, or monomial radicals by monomial. What happens if we're doing more than one multiplication? And I want to do these 3. Okay. Well, if I gave you this, what would you do to this? When you see this, what are you going to do?
2 times everything.
2 times everything inside. So you're going to take everything on the outside multiplied by, or sorry, you're going to take the thing on the outside multiplied by every term inside. Same with radicals. So for this one, we're going to have to take 7 root 3 and multiply it by this, and then go back to 7 root 3 and multiply it by that. And then, just like we were doing after, we see if we can simplify anything. So what is 7 root 3 times 5 root 5? Right. Plus. Okay. So not only do you have to look for simplifying when we start getting into these types of multiplications, also be aware that sometimes you might be able to take radicals, a square root or a cube root, exactly. Can I do anything to this? No, there's no perfect square, so I can't touch this. But what about this? 42 times, remember 42 root 9 means 42 times root 9. What's this? 3. So isn't this the same as 42 times 3? Which gives me what? 126. Good. And that's as far as I can go. So you got to be on the lookout for that. The next one, I've got 2 multiplications to do. What does the first term look like after I multiply those 2? Which looks like I can't do anything with. perfect square that goes into root 22. And then the next one, plus, because it's two negatives being multiplied, 8 root 12. You guys should be sort of at the point where you start recognizing a lot of these. Like when you see root 12, you're like, yeah. All set, I'm going to break down. Can't take it exactly, but I can break it down. 2, 4, and 3, which becomes 2 root 3. Saving myself a little bit of a step here. So I get negative 6 root 2 plus 8 times 2 root 3. 16 root 3. Finally, a little bit more challenging one. That magically gets crossed out. How many multiplications? 3. Don't get thrown by the letters and the exponents. You still multiply radicals the same way. What is root k times root k to the third? Root k to the fourth. What is root k times minus 2 root k? Minus 2. Good. And plus root k times 1. Yes. Look to simplify or take exactly. I can take it exactly. I don't have to find the highest perfect square because it is a perfect square. Minus 2k. I don't have to find the highest perfect square because it is a perfect square. So I can take it exactly. And root k, I can't do anything. And of course, you always want to check for like terms, but usually after you're doing the multiplying and simplifying of these, there's no like terms. Okay. So I'm going to stop there, and you can see sort of what happens next as we start getting into more multiplications. But let's make sure that we're comfortable with multiplying monomials together and monomials by binomials before we start moving on to these. Okay, so